Hey there, in this video I'm going to show you how you can make some quick and dirty graphs in your Jupyter notebook. These are mostly just for playing around. This isn't the style that you would use in a finished product by any means. What we're going to do is we're just going to tell the notebook to erase its output and then immediately redraw it. So basically we're going to print something, erase the output, print something new, erase the output. And as it happens, it's easy to code, but it's actually kind of slow, kind of clunky. It's just good for playing around. So we're going to need to import some controls to get our hands on Jupyter itself, or specifically the IPython backend that gives us all the Python control in Jupyter. So from IPython, we're going to import the display module, which lets us control the output that we see in our notebook. We're also going to import sleep out of the time module that is built into Python. So from time, import sleep. And what sleep does is it tells the computer to not do anything for a certain amount of time. Just a quick example. If I say sleep 2 seconds, and then after sleeping for 2 seconds, print done, run that, 1, 2, and then done. So it's just a do nothing function for a certain amount of time. And you can put these together so that you can say, wait a little while, redraw the output, wait a little while, redraw the output. Now in practice, this is so slow, you usually don't do sleep for very long, or you do it for like 100th or 1,000th of a second just to control things a little bit. But let's do a simple redraw type animation. So I'm going to make a for loop here for I in range 100. And what I want to do, actually let's make this 1,000 just for more fun. 1,000 times through here, what I want to do is I want to print I. Now this is the normal sort of print statement, so it line by line prints out all the values. If I want to change this so it just prints them on top of each other, erasing as it goes, what I can do is, right before I do the print statement, I can clear the output. So I could do display.clearOutput. That's the star of our show here. It has one optional argument, wait, and we pretty much always want to set wait equals true. What that means is don't clear the output until there's something new to draw. Because if you don't put wait equals true, what'll happen is it'll erase, and it might take a little while to do the next line. I mean, print's pretty quick, but some functions might take a while, and you're going to have a lot of time where the output is just blank. Whereas with wait equals true, it doesn't erase until it's ready to redraw. So you always have something to look at. In any case, if we run this approach, what we see is after each step, it erases and redraws. Now, unfortunately, it's kind of an expensive operation to have Jupyter redraw its output, because this output here has to be processed with Python code, and it's drawn using JavaScript in your web browser, and it's just like a lot of computing to do this. So normally a computer could do 1,000 operations in like a millionth of a second, like literally a millionth of a second. Here it's taking a few seconds to count up to 1,000. But it was kind of a nice visual effect as it went. And so, you know, for something quick, it's not bad. Unfortunately, if I now save and give you this notebook and you look at it, you're just going to see 999 in this spot. Because to see it count, you have to have Python running and you have to run the cell. So it's not good for giving to somebody else. It's kind of slow, but on the other hand, it's really easy to do. Let me show you another example where we'll do something a little fancier. Instead of just printing and erasing, let's draw a graph and erase the graph and draw a new one. Mostly just to show you how clunky it is so that you are motivated to learn how to make animations in Matplotlib, which I'll show you in an upcoming video. But for now, the quick version would be, let's make a for loop, and let's say I want 20 graphs just because I don't want to wait forever. And then I'll put my code to make a graph. So I'm going to have some x values. Let's say I want to print sine x with different phase shifts. So I'll need some x values. We'll do a linspace here of 0 to 2 pi. And let's do 100 of those for a pretty smooth graph. And then I'll plot x versus sine x. Now I don't really want sine x for all 20 of these, otherwise nothing changes in my plot. So let's give it a little bit of a phase shift. So the phase shift can range from 0 to 2 pi. And I want to scale it by whatever step we're on, I, divided by 20. So we'll scale from 1/20th of a phase all the way up to, well, I guess we'll start with I equals 0, so no scaling at all, up through 1/20th all the way up to 19/20ths, which would be like just the end of the cycle, so almost a full phase shift of 2 pi. And then plot.show. I don't want to run this just yet because I'm not clearing anything. So what it would do is give me 20 graphs all one after another. What I want to do instead is right before the plot.show, I want to clear the output. So we'll do a display.clear output. I want wait equals true again because I don't want to look at a blank screen. I want to see that as soon as the next thing's ready to draw, then it erases. So there's always something to view. Now if I run this, here we go, our real crude, kind of choppy, but you know, for playing around, it's pretty easy code to write. Just a for loop with a clear output. So it lets you quickly turn something static into something animated if you just want to get a quick feel for like what's going to happen when I animate it. But not a really nice finished product. It requires you to run it. It's kind of slow and choppy. So I'm going to show you in a follow-up video how to make a nice smooth video using Matplotlib.